All right, today we're going to light a candle, but not just any candle. We're using it to unlock one of the most brilliant scientific lectures ever given. We're going to dive deep into the 19th century work of Michael Faraday and his absolutely incredible explainer on the chemistry of, you guessed it, a simple candle.
I mean, that is a huge claim, right? The guy who edited Faraday's lectures, William Crookes, he was basically saying that if you understand this, you know more about fire than Aristotle. He believed that hidden inside this super common, everyday object were truths that the greatest minds had missed for centuries. And you know what? He was absolutely right.
And this gets right to the heart of Faraday's whole idea. He looked at a candle and didn't just see a light source. No, he saw a perfect, tiny laboratory, a little machine demonstrating the fundamental laws of the entire universe. So let's do this. Let's dive in and see exactly what he saw. Okay, first things first, let's start with what seems like the most obvious question, the first real puzzle, the fuel. Seriously, just think about it for a second. The fuel, the wax, is a solid block, right? It's just sitting there. But the flame, it's way up here, dancing in the air. They don't even seem to be touching. So what's going on? How in the world does that solid wax defy gravity and get all the way up to where the action is?
Well, Faraday explains that the whole process is this beautifully efficient, self-contained machine. It all starts with the flame's own heat. That heat radiates down and melts the very top layer of wax. And this creates what he called a beautiful cup of liquid fuel, just perfectly held in place by the cooler, solid wax around the edge. Okay, but how does the liquid get from that little cup all the way up to the flame? Well, this is where the real magic happens. It's a force called capillary attraction. You can think of that cotton wick as a kind of microscopic sponge or a bunch of tiny straws. It just sucks that liquid wax straight up, completely against gravity, and delivers it exactly where it needs to go, right into the heart of the flame. So the fuel has made its journey up the wick. But now, what is the flame? I mean, really, what is it? It's not just a simple blob of light, not at all. It actually has a pretty complex structure, an anatomy. Yeah, if you look really closely, you'll see it's not one single thing. It's more like a series of events happening in different regions. And each of those regions, each part of the flame's anatomy, tells a different piece of this amazing chemical story. And you can really see the two main zones here. That dark part on the inside, that's just a cloud of pure fuel. It's wax that's gotten so hot, it's turned into a vapor, but it hasn't found any oxygen to burn with yet. But that bright, glowing outer part, that's the combustion zone. That's the ring where that hot fuel vapor finally smashes into the oxygen from the air, and poof. But that brings up another question, and it's a really important one. Why is the flame so bright? Now, that might sound like a silly question, but Faraday knew that some things burn with incredible heat, like pure hydrogen gas, but their flame is almost invisible. So, what's making our candle glow with that brilliant yellow light? And the answer is just so cool. The flame's brightness actually comes from tiny solid particles of carbon, basically soot. You see, the intense heat of the combustion literally tears the wax vapor apart into its basic ingredients. And one of those is carbon. So for just a split second, you have these tiny solid bits of carbon floating inside the flame, and they get so hot they glow like crazy. It's the exact same principle as the filament in an old school light bulb. That's where the light comes from. Okay, so we've got fuel going up the wick, and we've got light being produced. But wait a minute. In the process, the actual solid candle wax is just disappearing. We all know you can't just destroy matter, so where does it go? What does the flame breathe out?
Right? When a candle is burning perfectly, there's no smoke, no soot left over, nothing. The solid chunk of wax just seems to vanish into thin air. So Faraday's next challenge was to actually capture and figure out what these invisible products were. And what he found was that the solid wax gets completely transformed, chemically, into two simple, invisible things. The first is water. You can actually see it for yourself if you hold a cold spoon over a flame. You'll see moisture condense on it. And the second is a gas they called carbonic acid back then, which we now know is carbon dioxide. So to really get how this transformation happens, we need to look at the three key players, the three elements involved. First up, you've got oxygen. Now, this isn't in the candle itself. It's all around us in the air. You can think of it as the essential partner the candle needs to breathe for the fire to happen. Okay, player number two is hydrogen.
This one is locked up inside the wax molecules. When things get hot, this hydrogen breaks free, finds that oxygen from the air, and boom, they combine to form our first product, water, which comes off as invisible vapor. And our final player is carbon, which also comes from the wax. And hey, these are the very same carbon particles we were just talking about, the little bits of soot that get super hot and glow to make the light. Well, once they've done their job making light, they get to the edge of the flame, grab onto some oxygen, and become our second product, the carbonic acid gas, or CO2.
Okay, hang on, because this is where Faraday's lecture takes this incredible, mind-blowing leap. He revealed that this whole process, this combustion, it's not just something that happens in a candle on a table. It is happening inside every single one of us, right this very second. You are a candle.
Just look at this comparison. It's absolutely astonishing. A candle's fuel, it's wax, right? Made of carbon and hydrogen. Our fuel, it's the food we eat, also made of carbon and hydrogen. A candle needs oxygen from the air to burn. We need oxygen from the air, which we get with our lungs. And the products? A candle gives off CO2 and water, plus heat and light. We breathe out CO2 and water, and we produce the heat that keeps our bodies warm. It's the exact same process.
And the scale of this internal fire happening inside living things is just immense. To put it in perspective, Faraday actually calculated that a single horse, just by breathing, burns through 79 ounces of carbon. That's almost 5 pounds, every single day, just to stay warm. We are all, in a very real, very chemical sense, just slow-burning candles.
So this incredible parallel, between a non-living flame and the actual process of life itself, this is what led Faraday to his final, profound, and really beautiful takeaway. And this is the final thought. In the end, Faraday's lecture isn't just a science lesson, is it? It becomes this powerful metaphor for life. He's saying, look, the reason to understand all these natural laws isn't just to be smart. It's so that we might be fit to compare ourselves to a candle, so that we, like a candle, might shine as lights to those around us, providing warmth and clarity, a truly illuminating thought.